Okay, so let's do another example on our acceleration practice worksheet, okay? All 5 of these questions are going to use the same formula, and that is the formula for acceleration. So before you start any of these problems, the first thing that we need to do is make sure we write down the formula that we're using, okay? And it's going to be this formula for all of the problems. So A, which is your acceleration, is equal to, and I'm going to go to Insert Equation, and I'm going to go to my math operations and click my fraction, because we're going to do a fraction here because that is going to be our formula. So our acceleration is equal to our final velocity, which is notated as VF, minus our initial velocity, which is VI, all over time. Okay, that is going to be the equation that we use for all of these problems. So acceleration is equal to our final velocity minus our initial velocity all over time. Okay, now the next thing we have to do is make sure we identify each of our variables. So before you do anything else, we need to write these things. We need to know acceleration, we need to know our final velocity, our initial velocity, and our times. Okay, so these variables right here are just the variables that are in the equation. Now, in every problem, you're going to be given 3 of these, and you're going to have to solve for one of them. Okay, so let's take a look at question 1. It says an ice cream truck is going 25 meters per second to the east. It accelerates to 40 meters per second in the same direction over 3 seconds. What is its acceleration? Okay, so acceleration is what we're looking for here. So I'm going to go ahead and put a question mark next to my acceleration because I know that's what I'm looking for. So I have to plug in the variables for VF, VI, and T in order to solve. Okay, so next let's look for our final velocity. So remember, VF is final velocity. So we're going to find that in the problem. Now, final velocity is what we end up. So what is the ending velocity? This problem says that the ice cream truck is going 25 meters per second. So that's where it starts, okay? But it accelerates to 40 meters per second. So that's going to be our final velocity because that's the ending velocity that's given to us in the problem, okay? So our VF is going to be 40 meters per second, okay? Now our initial velocity is where the ice cream truck started. So it started by going 25 meters per second, then it went to 40. So where it starts is our initial velocity. So that's 25 meters per second. Okay. So then our time is just going to be in seconds, and it tells us in the problem that this happened over a time period of 3 seconds. Okay. So 3 seconds is going to be our time period. So now we have these variables that we're going to plug in. Now, this particular problem had all numeric variables. Remember that if something is at rest or comes to a stop, then that would be 0 meters per second. So that will help us in some of these down here. Okay? Now what we have to do is plug in our variables to our equation. So I'm just going to copy my equation and put it over here so I can plug it in. Okay, and remember we're solving for A. So I'm going to go ahead and insert a new equation. And I'm going to plug my variables from here into my equation. So my VF is 40 meters per second. And my VI is 25 meters per second. Okay, so 40 minus 25. 40 was the VF, 25 is the VI. So our final velocity minus our initial velocity. Okay, and our time is 3 seconds. Okay, so that's what we do. So now I can start to solve and simplify. And this is just at this point a math problem. Okay, so I'm going to open up a calculator. I'm going to go and type in Desmos Scientific. And we're going to do 40 minus 25. which will give us 15. Okay, so on top, I have 15 meters per second over 3 seconds. Okay, now I can simplify again, and to solve this, because now this is just a fraction problem, we're going to do 15 divided by 3. Okay, so 15 divided by 3 is equal to 5. Okay, so my acceleration is going to be equal to 5 meters per second squared. All acceleration units are in meters per second squared. So your answer here is 5 meters per second squared. Okay, so this is the process that you're going to do for this whole worksheet. Okay, so we always start by writing our formula. This is going to be the formula for all of these different problems. Okay, so this is what we should start with. Step 2, you're going to identify your variables. So what's your final velocity? What's your initial velocity? What's your time? What's your acceleration? Remember, you'll be given 3 of these values and asked to solve for one of the variables. Okay, so then once you can do that, you just plug and chug into the formula. Remember, with fraction formulas, you just do the subtraction on the top, and then whatever's on the bottom, like once we get here to the fraction, you just have to divide. Okay, so that's just basic algebra. I did number 4 in that video that was already in the assignment. So number 1 and number 2 are exactly the same. But for number 2, it says a soccer player is running upfield at 10 meters per second. So that's his initial velocity. So when you're working this one, your VI is going to be 10 meters per second. Okay, so the VI is 10 meters per second. Then it says he comes to a stop in 3 seconds. This here where it's saying comes to a stop, that's going to be our indication that the velocity comes to 0. Okay, so your VI will be 10, your VF will be 0, and then your time is given to us in 3 seconds. Okay, so you'll use the same formula, but here your VF is going to be 0, your VI is 10, and then your time is 3. Okay, so same process for 2 as we just did in number 1. Number 3 is similar to number 4, and number 5 is also similar to number 4, which is what I did in that explain video where I worked this problem for you. You're using the same equation here. So we use the same equation, except this time we have to put different variables into the problem. So we're solving for a different variable. So let me just go ahead and do 3 for you as well. And then 5 will be just like 3. Okay. So here we have a turtle. It's accelerating from a stop at 3 meters per second. Here it says it accelerates from a stop. Okay, now this 3 meters per second squared tells me that's my acceleration, because that is the unit for acceleration. So we have 3 meters per second squared. Okay, there's our acceleration. Our VF, we don't know the VF because the problem is saying what is the turtle's final velocity. So that's what we're solving for in this one. Okay, our VI here, it says it accelerates from a stop. If something is accelerating from a stop, that means that the VI is 0 meters per second. Okay, and then our time is just the time it gives us, and that is in 8 seconds. Okay, so just like before, we're going to use our same formula, but this time we're solving for VF instead of A. Okay, so here our acceleration is 3 meters per second squared. And we're going to plug in what we know. So we don't have a VF, so we're just going to go ahead and type in VF because that's what we're solving for, minus 0 meters per second, because we know that is our initial velocity, all over 8 seconds. Okay, now here we have to do some cross multiplication. Again, this is algebra. So because we're trying to get the VF by himself, we're going to have to multiply the 3 and the 8. So we'll do 3 meters per second squared times 8 seconds is equal to our VF minus 0. Okay? Now we have to solve for VF. Thankfully for us, this is going to be pretty easy. So to solve and get VF by himself, we just want to eliminate that 0, which it's 0, so we don't actually have to do anything, but I'll show you just the proper way to do that. So 8 times 3 is 24. So 24 meters per second, because it is a velocity we're solving for, is equal to VF. Okay, so your answer here is 24 meters per second. Okay, this, again, it's the same thing as number 1. All of these problems are exactly the same. You're using this formula. You have to identify the different variables, and then it's just plug in and solving it algebraically. Okay, so that's 1, 3, and then I did the video in the assignment for 4, so I need you to do number 2 and number 5 on your own. So give those a try. You have 3 examples there. Number 2 is the exact same type as number 1, and then number 5 is the exact type as number 3. Okay, so you have examples there for those. Give those a try and then let me know if you still need some help.